Somewhere in the early universe, a galaxy is dying. Not exploding, not colliding, dying. Slowly having the life pulled out of it. For years now, astronomers have kept finding galaxies that were already dead when the cosmos was barely a toddler. These dead galaxies had finished making stars far too early, and nobody could quite explain how they got that way so fast. We found plenty of corpses, but what we'd never seen was the murder actually happening. Until now. Using the James Webb Space Telescope and ALMA, a team of astronomers thinks they've caught one in the act, and the image shows exactly what's doing the killing. To see why this discovery matters, you need to know about one of the more stubborn puzzles in modern astronomy. When we point Webb at the deep, early universe, the first billion or so years after the Big Bang, we expect chaos. Galaxies furiously building themselves, gas everywhere, stars igniting by the billion, and we do see that. But we also keep finding something we shouldn't. Galaxies that are already finished. Astronomers call them red and dead. Red because without new, hot, blue stars, all that's left is the dim red glow of older ones. And dead because star formation has essentially stopped. These are massive, mature-looking galaxies sitting in an era that's supposed to be all about growth. It's like walking into a nursery and finding a retiree. So the question becomes, what shut them down? What could reach into a young galaxy, one still swimming in the raw gas it needs to make stars, and switch off the lights this early? One suspect has always been the galactic neighborhood. In today's universe, galaxies and big, crowded clusters can get their gas stripped away as they plow through the hot gas that fills the space between those galaxies. But that process was thought to need a mature, settled cluster with a hot, dense atmosphere already in place, and in the early universe, those aren't supposed to exist yet. Which brings us to the crime scene. The galaxy is called C26, and it lives inside a protocluster, a galaxy cluster still under construction, with the memorable name SPT 2349-56. We're seeing it as it was when the universe was just 1.4 billion years old, roughly a tenth of its current age. Its light has been traveling toward us for about 12.5 billion years, and when Webb imaged C26, it didn't look like a normal galaxy. Most galaxies are blobs, or spirals, or smooth ellipses. C26 looks like a comet. There's a compact head packed with stars, and then a long tail streaming off to one side, stretching tens of thousands of light years. Then the team brought in ALMA, the giant array of radio dishes out in the Chilean desert that sees cold gas instead of starlight, and the picture got even stranger. The cold gas, the raw fuel a galaxy uses to build new stars, wasn't where the stars were. It was shoved off to one side, trailing behind in that tail we just discussed, offset from the galaxy by thousands of light years. Think about how strange that is. The stars are in one place, and the gas the galaxy needs to make new stars is somewhere else, essentially being left behind. And it's not a trickle. More than half of the galaxy's observed cold gas has been dragged out into that tail. Something peeled the fuel right off of the galaxy, leaving the stars behind like a car coasting to a stop after the tanks run dry. The question is, what? And this is where it turns into a proper whodunit. In the early universe, when you find a galaxy that's been violently rearranged, there are two usual suspects. Suspect number one, a collision. Galaxies in crowded regions smash and merge all the time, and a close gravitational pass can fling gas and stars out into long streams. It's a process called a tidal interaction, and it's the default explanation for most disturbed galaxies. Now, suspect number two, the environment itself. As a galaxy falls through a cluster, it isn't moving through empty space. It's moving through a thin, blisteringly hot atmosphere of gas that fills the whole cluster. And when a galaxy plows through that atmosphere fast enough, the pressure acts like a headwind, pushing the galaxy's own gas out the back. Astronomers call it ram pressure stripping. In the nearby universe, it creates spectacular jellyfish galaxies, trailing tentacles of gas behind them. So which suspect is it for C26? Here's where the team plays detective. If a collision had done this, you'd expect to find the other galaxy, the thing C26 crashed into. But there's no massive companion. There is a small knot of stars downstream, but it's tiny, less than 15% of the mass of the main galaxy. That's just far too small to have caused this kind of damage. A merger also tends to light a galaxy up, triggering a firestorm of new stars as gas slams together. C26 isn't doing that. It's forming stars only modestly, and the gas in its tail is calm and diffuse. Exactly what you'd expect from gas that's been gently peeled away, not violently smashed. And then the clincher. Remember how ram pressure stripping needs a hot cluster atmosphere? The kind that supposedly shouldn't exist yet, this early? Well, astronomers had already independently detected exactly that. A reservoir of hot gas in this specific protocluster, hotter and denser than anyone expected for a cluster so young. The murder weapon was there all along. But hang on. If hot cluster atmospheres shouldn't exist this early, and the explanation depends on one, doesn't the story undercut itself? Here's the resolution. That expectation was about typical young clusters, and SPT 2349-56 is anything but typical. It's one of the most extreme protocluster cores ever found. Dozens of galaxies packed into a patch of space smaller than the distance between the Milky Way and Andromeda. The early universe was a denser place too, so gas funneled into a core like this gets squeezed far harder than it would today. And the core hosts actively feeding supermassive black holes that can stir and shock the gas around them. The leading explanation is that all of this together built an atmosphere hotter, denser, and more turbulent than a young cluster has any right to have. So it's not a contradiction, it's a correction. Hot atmospheres can form this early, at least in the universe's most extreme corners, and this one got caught red-handed. Added up, the comet shape, the calm displaced gas, the missing collision partner, the hot atmosphere, and the evidence points one way. C26 is being strangled by its own environment, its fuel stripped away as it falls through the cluster. So, a galaxy is being stripped of its gas. Why is that a big deal? Two reasons. The first is timing. Ram pressure stripping like this was thought to be a late stage thing, something that happens in mature, settled clusters that took billions of years to build up their hot atmospheres. Finding it here, in a cluster still under construction just 1.4 billion years after the Big Bang, means the environment can start killing galaxies far earlier than we assumed. And this is not a small step. The previous early examples that we had identified, gas tails in a forming cluster and in a compact group, date to around 2 billion years after the Big Bang. C26 pushes that back by roughly 700 million years. And those earlier cases are mild, gas being disturbed, not a galaxy actually being killed. Whether stripping could get violent enough to shut down a massive galaxy this early was still an open question. C26 looks like the first answer to that open question. The second reason takes us right back to that graveyard of red and dead galaxies. If a young galaxy can have its fuel torn away this early, then here, potentially, is part of the answer to how these galaxies died so soon. Not because they burned out from the inside, but because their surroundings starved them. C26 might be a snapshot of exactly that transition, caught in the middle of the process. A galaxy that still has its stars, still has some gas, but has already lost more than half of its fuel and is on a one-way road to becoming red and dead. And there's a bigger picture hiding here as well. Cores like SPT 2349-56 are thought to be the construction sites of the largest galaxies in the modern universe, the giant ellipticals that anchor today's clusters. If that's right, then this may be a baby picture of how today's galaxy graveyards were made. Clusters that started killing their own galaxies before the cluster itself was even finished. The nursery and the graveyard were the same place all along. It also makes a testable prediction. If the environment really is an early killer, the dead galaxies JWST keeps finding shouldn't be scattered randomly. They should pile up in dense neighborhoods like this one. That's something upcoming surveys can check. Now, a dose of honesty, because this is still fresh science. This is a single galaxy, and the paper is a preprint, which means it hasn't been through full peer review just yet. The interpretation is careful, and the evidence lines up nicely, but it's just one case, not a population. That doesn't mean it's not exciting though, and what makes it exciting is that C26 isn't alone. Other galaxies in the same cluster core also look surprisingly gas poor, hinting that this stripping might be reshaping the whole protocluster in its entirety, not just one unlucky member. If that holds up, this isn't one murder caught on camera. It's a first look at how entire generations of galaxies were shut down, far earlier than anyone thought possible. There's something almost poetic about it. We spent years finding the graveyards, galaxies that were already dead when the universe was young, with no explanation of how they got there. And now, in a galaxy shaped like a comet, 12.5 billion years in the past, we might finally be watching one of those deaths as it actually happens. I've linked the paper below if you want to dig into the details. If you got something out of this, hit subscribe. It genuinely helps the channel. And here's my question for you. A galaxy that's lost its gas but still has its stars, is that actually dead yet or just dying? Let me know what you think down in the comments. And as always, I'll see you in the next one.